Okay, let us do some problem on constant acceleration. Exercise number 1. If a car at rest accelerates uniformly to a speed of 144 km per hour in 20 seconds, it covers a distance of either option A, B, C, or D. How do we do this problem? Okay, so it says here a car at rest. So once they say that a car is at rest, so it means that the initial velocity of the car will be 0. It accelerates uniformly to a speed. That means there is some acceleration which we don't know. Okay, and finally its speed that it attains, v, is 144 km per hour. So here you can see that the answer is in meter, not kilometer, which means that I have to convert this to meter per second. So how do I convert this? Kilometer. So I have 144 kilometer, convert this to meter. 1 kilometer is how many meters? 1000 meters, right? Divided by 1 hour. 1 hour is equal to how many seconds? 3600 seconds. So now this will be meter per second. So if you do some cancellation, this and this will go 36, and this will go 4. So 4 into 10, this will be 40 meter per second. Okay, right. So here it covers a distance of how much? That means you need to find the distance. All right, so how do we find the distance? We have to use a number of formulas. So first of all, there are two steps in which you can get the answer here. First of all, you have to find the acceleration. So you know the value of u, you know v, and time also is given. T also is known. So which formula to be used in order to find a? Are you familiar with this formula? V is equal to u plus at. Yes, so using this formula we can find a, right? So here you get v, which is 40, u here is 0, plus a here is you don't know a, and time here is 20. So basically here a is how much? 2 meter per second square. So after finding a, now you can use the formula. Now use the formula S is equal to ut plus half at square. You can find the value of S. So obviously u is 0, so this part will be 0. So you have only half a is 2, and time here is 20 square. Okay, this and this will go, and 20 square here is 20 into 20, which is 400 meters. So which is the correct option? Option B. That's the correct option. Exercise number 2. A body starts from rest. Again here, since the body starts from rest, u will be 0 and moves with a uniform acceleration of 10 meter per second square. So the acceleration here is given. A is 10 meter per second square for 5 seconds. Time here is given to be 5 seconds. During the next 10 seconds, it moves with uniform velocity. So here there are two sections of the problem. So in the first part of the problem, the body is moving for 5 seconds. And in the second part of the problem, it is moving for 10 seconds. All right. So in the next, let's call this T1. Okay. And in the next in the next 10 seconds, it moves with uniform velocity. Uniform velocity means what? Means the acceleration is 0. Okay. So here A2 will be 0. Let's call this A1. All right. So in the second time, T2, which is 10 seconds, A2, this is 0. How do I know that A2 is 0? Because in the second part, it is moving with uniform velocity. Okay, uniform velocity means the velocity is constant and it is not changing. And if the velocity does not change, its acceleration will be 0. Okay, so what do we do here? Let us draw the line. Okay, this is our very important line. Whenever you do these kind of problems, always you have to draw this line. Let's call this point A, and at point A u is 0. Alright, so this body is moving for 5 seconds. Let's say it reaches point B after traveling t1 5 seconds. Okay, and it accelerates a1 with how much? 10 meter per second square. So from rest it accelerates, and therefore it attains some velocity here, v1, which you don't know. Okay, so the distance that it travels in the first part, let us call this distance to be s1. Let this be s1. Okay, so here we are going to find the value of s1 because they are asking us to find the total distance traveled. All right, so total distance will be s1 plus this next distance. Okay, so in the next part of the problem it says that in the next 10 seconds, so t2 here is 10 seconds. Okay, it reaches point C. And what does it say? It says that in the next 10 seconds, so that means from here till point C, it is moving with uniform velocity. So if it starts from B with v1, then it will end at C also with a velocity v2, which is equal to v1 only. Yes or no? Because going from B to C, it is going with uniform velocity. And what is the value of a2? A2 here is 0. Let the distance from B to C be s2. Let this be s2. So all we need to do is to find the value of s1 and s2 and then find the total distance. So how do we do this? How do we do this? First of all, let us find the value of v1. Okay, how do we find the value of v1? We know u, we know a, we know t. Very easy. So using v1 is equal to u plus a1 t1. So v1 here, u is 0, a1 is 10, t1 is 50 meter per second. That is v1. Now let us find s1. How do we find s1? S1 using the formula s is equal to ut plus half et square. So this will be ut1 plus half a1 t1 square. Again, this part will be 0. Why? Since u is 0. So you have half. What is the value of a1? A1 is 10. What is the value of time? Time here is 5. So this will be 5 square. 5 square is 25. Okay, so this and this will go 5. 5 into 25 is 125 meter. So we got the value of s1. Now let us find the next things. Okay, in the second part now. In the second part, what we can do is we can just use s2 is equal to v1 t2. Why? Because v1 is the velocity that it goes from B to C. And in what time? t2. So here v1 is how much? 50, right? 50, the time is 10. So 500 meter. So what is the total distance? Therefore, total distance is s1 plus s2, 125 plus 500. This comes out to be 625 meter. And what is the correct option? Option D is the correct option. Problem number 3. If a train traveling at 72 kilometer per hour is to be brought to rest in a distance of 200 meter, then its retardation will be what? So basically this train is traveling at this speed. It has to stop within the distance of 200 meter. So when it stops, what will be its speed? Its speed would be 0. Yes or no? So that means this is the initial speed of the train, 72 kilometer per hour. And just now we have okay, 72, how do we convert this to meter per second? So 72 kilometer is 1000 meter, and divided by hour. 1 hour is 3600 seconds. So again I do some cancelling. This 36 and 72 will go 2 into 10. This will be 20 meter per second. Okay, is brought to rest. Brought to rest means the final velocity v will be 0. Okay, in a distance of s is equal to 200 meter. Then its retardation, that means a is how much? Okay, so can you think of a formula that connects v, u, s and a? Can you think of that formula? Which formula we use? We use v square is equal to u square plus 2as. Alright, so from here you put the values, then you can find the value of a. Okay, a here will come out to be negative. Why? Because it is a retardation. So I want you to complete this by yourself. Problem number 4. Okay, if a car at rest accelerates uniformly and attains a speed of 72 km in 10 seconds. So again here, let us write down the given quantities. So the trick is, whenever you do a physics problem, always write down the given quantities. Okay, a car at rest means the initial speed of the car is 0. It accelerates uniformly. So a here is uniform. You don't know the value of a, but we know that it is uniform, and attains a speed of 72. That means this is the final speed of the car, 72 km per hour. And please don't forget the unit. Now you convert this to meter per second, you get 20 meter per second in 10 seconds. So time here is 10 seconds. Then it covers a distance of, you have to find the distance s, how much. Alright, so here you can just use, first you will find a. Okay, find a. I'll tell you the steps. Alright, first find a is equal to how much, using v is equal to u plus 80. So that's the first step. The second step, find s is equal to how much, using which formula now? S is equal to ut plus half 80 square. Okay, so you should get 100 meter. The previous problem, the answer should be 1. You'll get -1. Okay, but since the minus sign, it only denotes that it is a retardation. So you should get, you should get, again unhide this. You should get this as the answer. Okay, so this one we have discussed. Okay, we go to this one, number 5. So in this problem, a stone is dropped into a well in which the level of water is h below the top of the well. So we understand that there is a well out here. That's not a well, but let me rub off this part. Okay, so, and then somewhere here is the level of water. Okay, and it says that the height of the well is how much? Height of the well means what? Not till the bottom of the well, till the level of the water. That is what it means. Okay, and the height of the well is given to be h. Right? A stone is dropped into a well in which the level of water is h below the top. That means from here till the water, we're not counting this part, okay, is h. If v is the velocity of sound, the time t after which the splash is heard is given by what? So a stone is dropped. So let this stone be here. When we say dropped, there is a difference between dropped and throw. Okay, if we drop and if we throw, what is the meaning? Drop means you're just holding it in place and you are releasing. You release from your hand. So you're not moving your hand, you're not moving the stone, you just release it. Throw, that means you are providing some initial speed, initial velocity. So here, when we say that the stone is dropped, what do we mean? We mean that the initial velocity of the stone, this is 0. All right. So it will fall downward like this, traveling a height h. And what will be the acceleration? Acceleration, obviously, this will be equal to the acceleration due to gravity because it is falling downward. So let's say it reaches the water in time t1. Okay, let's call this t1. All right. So here we have to first find what is the time t1, and let's say it reaches, or it's when it just about to touch the water, its velocity is v1. We don't know the value of v1, and we don't know the value of t1 as well. Okay, we don't know this. What is t1? T1 is the time that it goes from top to the water here. Okay, so how do we do? Let's do like this. Let's use v1 square is equal to u square plus 2gh. So obviously u here will be 0. So what will be the value of v1? v1 is 2gh under root. Call that some equation 1, right? So now we have v1 is equal to u plus g t1. Yes, using the formula v is equal to u plus at. Instead of a, you write g out here, right? So this will be 0. But what is the value of v1 obtained from equation 1? This is 2gh under a root. So this is g t1. So t1 will be 2gh under a root divided by g. All right. So t1 here will be what? Can I do like this? 2gh under a root. Can I write root g square? Can I write like that? I can do this. Yes, because I can cancel this root and the square. So I will get back g. So instead of writing just 2 square roots like this, I can now write only 1 square root. Yes. So that is the rule, isn't it? So 1g and 1g will cancel. I will get here 2h by g under a root. Okay. So now for the second, this is the first part for falling. Now what will happen? The water will splash and sound will travel up with velocity v2, with velocity v. Here the velocity of sound is given. Okay, the time t for which, okay, if v is the velocity of sound, so this sound will go up with velocity v. And what is the distance that it travels? It travels a distance h, right? So now we use s is equal to vt. So instead of s, we write h, v, and the time it reaches the top is t2. So T2 here will be h by v, right? So from the time you release it, the stone goes down and takes time T1. Now the splash, the sound goes up, it takes time T2. So therefore, what is the total time? Total time here will be T1 plus T2. T1 is 2h by g under root plus T2 is h by v. And which is the correct option? This one. That is the correct option. Okay, next problem, number 6. A body falling from a height h takes T1 time to reach the ground. Okay. Solution. A body falling from a height h. Okay, let me draw this diagram. Okay, so it says a body falling from a height h. Okay, again I have to draw another from here till the ground. That height is h. Okay, this will be h. All right, so falling, it says falling, so again here it falls from rest. Okay. All right, so height, it takes time T1 to reach the ground. So it takes time how much? T1. T1 is the time that it goes from the top to the ground. Okay, the time taken to cover the first half of the height is how much? So now first half of the height, so at this point, this distance from here till here is h by 2. That's h by 2. All right, so let's say it takes time T2 to cover this. So now we need to find the value of V1. V1 is how much? Is it necessary? Okay, I think this is not necessary to find V1. So what we do is the first part. First of all, we find T1 for the first part. First part is in going from the top to the bottom. So let's use this. H is equal to U T1 plus half G T1 square, and U here is 0, so 2H by G is equal to T1 square. So T1 is 2H by G under a root. So that's the first part. Now second part is from going from here to this point only, and we'll use the same formula. Now the time is 2. Now h by 2 is equal to u t2 plus half g t2 square. So this implies h by 2 is equal to half g t2 square. So this half and this half will go. So T2 is h by g under a root. Equation 2. So therefore, if I compare this and this, isn't not T1 is equal to only this part, root h by g, isn't that equal to T2? So this T1, this equation 1 will become root 2 times of T2. Okay, so is there T2 is no, so let us do like this. T2, this root 2 will come down, T1 by root 2. All right, so which is this one? That is the correct option. Okay, So now let us do this one, number 7. Now, number 7 is a little bit different. We have to use this formula. Let us write here S th is equal to u plus a n minus half. Okay, we have to use this. All right. A body starts from rest. So a body starts from rest. What is the ratio of the distance traveled by the body during the 4th and the 3rd second? Okay, so u here is already 0. So it says that during the 4th and the 3rd second. So s, what is the ratio of the distance? So s 4th, we don't know. Okay, and the value of n here is 4. Similarly, s 3rd, we don't know, and the value of n here is 3. So let us use this formula to find s 4th. S 4th, use that formula, u plus a, n here is 4 minus half, u is 0, so you get a, 4 2 4 8, 7 by 2, 7 by 2 a. Similarly, s 3rd is u plus a, 3 minus half, u is 0, so you get 2 3 is 6 minus 1 5, 5 by 2 a. So therefore s 4th divided by s 3rd will be what? Is 7 by 2a into 2 by 5a. This and this will go. This will be 7:5, which is this answer. All right, so these are the sample problems from this topic, the constant accelerations. I will be giving you some homeworks. I want you to work out those homeworks. Thank you.